Thank you for being here today. My name is Elias Gossein. I'm really happy being with you today to talk about automation and customization. So just before starting the presentation, just give you a brief introduction about myself. I've joined Maya about 10 years ago, I think. Time flies. When I joined Maya 10 years ago, I started in the consulting services department group, where I was doing mostly structure and thermal analysis for our customers. Then I moved on to more on the software development side. And in the last 3 or 5 years, I think, I joined the customization group at Maya. We have a dedicated customization group. We have 15 really best-in-class developer and solution architect where we implement customization for our customers. And lately, I'm more acting as a solution architect. So if you ask me on a daily basis what I'm doing, just try to find best-in-class solution for our customers and implement them just to enhance their workflow, streamline their processes, and at the end of the day, improve their productivity and increase their business. So I will start my presentation by asking a very simple question, okay? Why do you think we need automation? Why do we use automation at first place? If I ask you this question, what is the first answer that comes to your mind? The most trivial answer is repetitive task, right? We all know that with automation, you can reduce, even eliminate any repetitive task in your workflow. So you can save resources, money, and time so that you can allocate to more complex and challenging tasks within your organization, right? We all agree on that. Second reason, human error. When you do automation, when you implement automation within your workflow, you can reduce, even completely remove any human error from the equation, especially when you're doing things that need a lot of detail, like CAD design, for instance. If you do automation and you are able to remove these human errors, at the end of the day, you don't need to ask yourself, did I make it right or no? Third reason, complex engineering problem. We will see together, and in a few minutes, I will show to you during my presentation how we were able to solve very complex engineering problem using automation that, at first place, if you want to tackle them with a manual approach, will be unreachable. And finally, and in my opinion, this is the most important reason why today we should use automation, is business rules. With automation, you can capture knowledge, you can incorporate business rules, because you, generally as a business, you have standards, right, that you need to meet to make your customer happy at the end of the day. So the question here is, how do you make sure that you are following these standards, these best practices? And how you make sure that your engineer working within your organization are following this standard at first place? And if we think it further, where do you store this knowledge in your company, in your organization? Where do you store this standard? I've seen lots of companies storing their knowledge in some PDF document on a server, or even worse, storing them in the mind and head of their senior people. So the question is, what would you do when the senior people will go to retirement? How you will make sure that they will transfer this knowledge to younger people in the organization? It has been shown that automation, and more specifically software, is the best vehicle to store and capture knowledge from generation to generation. So with automation, if you are able to add on top of that a layer of customization, you're making sure that you will tailor this automated tool to meet their specific needs and therefore increase their efficiency. So why I'm here today? The reason is very simple, because at Maya, we have been challenged hundreds and hundreds of times with complex engineering problem. And if I want to show you what we have been able to solve as problem, I need to speak for a week. Unfortunately, today I only have 40 minutes. So what I will do with you today is I will just stick to 5 relevant examples where we were able at Maya HTT to help our customers to increase their efficiency and therefore improve their business. And this example, I not randomly, but explicitly choose them to cover multiple areas of expertise, multiple domains. So I will cover CAD design, drafting automation. We will also see how we can use automation to enhance the collaboration between MCAD and Ecad engineers. I will show you as well an example how we were able at Maya to leverage automation and customization to improve the CAM coating process in manufacturing. And finally, we'll see an example how we can use automation to accelerate and have more accurate finite element analysis and structure simulation analysis. So I will start by the first problem that we were able to tackle at Maya, pipe routing. The problem is very easy, but at the same time, it's very complex. Because pipe routing is a very complex activity in the engineering world. Why? Because it depends on multiple factors that a pipe routing engineer needs to take into consideration. First of all, you have to take into consideration the fluid characteristic, the geometry, the complex of the geometry, and the surrounding geometry, the coordination of multiple systems, for example, the mechanical, electrical system, the cost and efficiency, and finally, the safety and regulation. From this characteristic here, I will just pick one, the complexity of the geometry, and I will show you what we did as an automated tool at Maya to be able to tackle this problem. So I will take an example of a turbocharger where I want to design some pipe routing. So this is an NX. What we do is you just launch a simple tool that you define where you want your pipe to start and where you want it to finish. And automatically, what the tool will do is it will compute the best route for your pipe by avoiding collision between the surrounding geometry. So we can do it for the first pipe, for example. Then you can move on to the second one. You can define some geometrical property like minimum offset, the minimum length of the tube, the minimum straight in the tube. And the algorithm will compute automatically the best routing for your pipe. What you can also do is add some waypoints. So you want your pipe to pass through some specific point, and the tool will capture this information and compute the best route for your pipe. I just want to emphasize on one point here is, here we're using NX. We just use NX for gathering the input from the user and showing the result back. But all the algorithm, all the solver has been implemented in an external piece of software. So this piece of software can work with any 3D package, not just NX, but because all the logic and the algorithm has been implemented separately. Second problem, drawing generation. So one customer come to us, he's dealing with IC packaging, and he wants to automate the generation of the drawings. Generating drawings is a very time-consuming task, and especially for IC packaging, because there is a lot of small details you need to take into account. For example, you need to create multiple projection, cross-sectional view. You have a lot of GDT to add. And also in the IC packaging world, the drawings that you need to generate depend on the type of the packaging you have. So the characteristic for BGA, for example, components are not the same for LGA. So the drawing standards are different. So what the customer asked us to do, because he told us it took between 4 and 5 days to generate one drawing for IC packaging. What he wants is, in a simple click button, to be able to recognize the type of the IC packaging and to generate the drawing automatically. So what we did, here, for example, is an example of a BGA. So here we can see you have the middle cavity, you have the ball grid. We imported the pad stack component. And so just showing you, this is the bottom view of the package. We have the top view. All the views have been defined on the board. And now we just launch a simple tool called drawing generation. Enter some properties, like, for example, the minimum padding between the PMI and the annotation. Click OK, and what the tool will do is not just generate a drawing, but also generate the PMI on the 3D automatically. So we'll take your 3D model, add all the PMI or the GDTs, go to the drafting application, and generate automatically the drawing. It will generate multiple sheets. For example, for the first sheet, it will generate the top view of the main board with a cross-sectional view, for example. And for each pad stack component, you will have your own projection view with the PMI and also GDT automatically added. Just to give you a rough order of magnitude, it takes around 5 minutes to generate one drawing. while initially it was taking between 4 and 5 days. So just imagine the time you can save by using such tool in your workflow. And as I said, it's not just not generating drawing, but also adding PMI on the 3D, so you have the both worlds. And then, of course, if the user, for example, is not satisfied with some placement of the annotation, he can then move them. But 90% of the job is done for him. And it recognizes the type of the board. For example, this is for a BGA, and BGA have a specific annotation where that should be put at a specific place. For LGA component, the standards are different. And that's where I was talking about capturing knowledge and business rules. The tool itself can capture and recognize on which type of board you're dealing with, and then create the drawing appropriately. Ecad MCAD collaboration. And this is an interesting topic for me because my background is a mechanical engineer. My wife is an electrical engineer, so doing MCAD, Ecad collaboration, I'm doing it on a daily basis. So I always have fun with my wife, like when talking about this topic. And it's a very interesting one. And generally, the problem is, let's say you want to design a PCB board, okay? The MCAD engineer needs some component to add on the board. He will contact the Ecad engineer. For example, I need a capacitor or a transformer, give it to me, give me the footprint, the 3D model, he will add it on the board. Then 2 days later, the electrical engineer will update the component. He needs to contact back the MCAD engineer. The MCAD engineer needs to update the board, and so on. So it's a back and forth communication between Ecad and MCAD engineer. What we did at Maya is we were able to use customization and automation to enhance and leverage this communication between Ecad and MCAD. Because what I've seen so far for many customers, from startups to big companies, is generally the Ecad engineer have their own library of EDA component, and mechanical engineer have their own library, and this library does not talk to each other. They are not in sync. If any update happens into one library, it's not automatically transferred to the other library. And so what we did is the customer, in this case, was using for the EDA side, for the Ecad side, Allegro from Cadence, and for the MCAD side, by using NX and Teamcenter. And what he asked us to do is to be able to bring all the EDA component into one place, one source of truth, which will be Teamcenter. So he don't need to worry about any synchronization between library. Everyone will pull all the EDA components from one place. We are sure that we have the greatest and latest version of that component. And if any update happens on any component on your board, everything is done automatically. You don't need to worry. So basically, Ecad and MCAD engineering does not need to talk to each other anymore. Everything is handled by automation and by customization. So the customer has its own library of footprint coming from Allegro, stored in a DRA file. He has another library of the 3D model of its EDA components stored in step file. And what the customer asked us to do is to be able to bring all this information into Teamcenter. So what we did at Maya is we were able to implement what we call the Ecad importer that will read the information from the footprint, read the information from the 3D step, and create a geometry in NX and Teamcenter containing all the footprint information and the 3D model, and store that information in Teamcenter. I will show an example in the next slide. Here, the customer were using Allegro and for EDA and Teamcenter NX for the MCAD, but the architecture of what we did is applied to the same any combination of EDA and MCAD software. It's the same. It's just a question of API, how you read the information from the Ecad side and how you read the information from the MCAD side. So let's see an example of a component that has been added to Teamcenter using the Ecad importer. So here we can see that you have your 3D geometry. In red at the bottom, you have your footprint information. So you have the pin curve, the pin label, the MMC is what we call the maximum material condition. The MMC curves that come from Allegro that we were able to extrude and create the purple body, what you can see here. So the MMC is like the envelope body where you know that this is the place that your component will take on your board. Okay? So it's very useful information for the MCAD engineer. We were able also to detect the location of, can I go back? Yeah, you can see here on the top, on the bottom, you have the pin colored in red. It has been automatically detected by the tool, and this will allow the MCAD engineer to know that your 3D model are perfectly aligned with the footprint. And this pin number 1 is used downstream in the process, for example, if you are using PCB Exchange for your analysis. And what we did is we were able to store all this information in a smart way in NX by creating the appropriate reference set and layers. We'll see it in the movie in a few seconds. But why we did this is because the customer was using Active Workspace, so he was designing his board. He can go to Active Workspace, access any type of component. So for example, he wants to add a transformer with 16 pins. Okay, so we create the right classification structure in Teamcenter, and we store all this information. So we imported approximately 10,000 components in the right buckets in Teamcenter. So the customer, when using Active Workspace, can search for any component. Okay, I want to add a transformer, for example, with a certain number of pins or certain tolerances. He drag and drop on the board, and he place it, and that's it. And then with the reference set concept, what he can do is he can switch back and forth between the 3D representation and the footprint. And can he see the footprint on the PCB board? So this is the reference set that we were able to create. So you have one for footprint, one for the maximum material condition, the MMC, that you can turn on and off. And so this will be really useful when you will add this component in the context of an assembly on the PCB board, for instance. Perfect. Next topic, CAM automation. So here's the problem. The problem is, the question is very simple. I have a part that you can see on the right here. I'm telling you that I want to start from a pre-finished blank or from a stock raw material. I want to go from the left side to the right side. Okay? The question is very simple. But answering that question is something else. Because if I want to go from the left to the right, how many manufacturing operations do I need to do to go from here to here? How many tools I need? How can I achieve this in how many setups? One setup, is it enough? I need 2 setups, 3, I don't know. So the customer has a web portal where its customer can go and submit any CAD part in any format, in PRT, STEP, IGS, any format. And what they want to know at the end of the day is how much it will cost to manufacture that part. And the answer should be provided within 1 minute. So he upload a final part. He tell the web portal that I want to start from a given pre-finished blank or from raw material. And what I need is how much it will cost me to go from A to B. What we did at Maya is we were able to implement a tool that will take the final part, will take the initial part, and will try to find all the clamping candidate phase where you can clamp the part and machine the part. So for example, I have a part. Okay, I say I can clamp it this way. If I clamp it this way, I can reach 3 features. But if I clamp it this way, I can reach 5 other features. I need to do this setup before the other one. So the tool were able to find what are all the clamping faces possibilities. And from this candidates, to find the optimal one. Which one I can pick, which allow me to go from A to B in the fastest way and in the cheaper way. Let's say it like this. And once the tool finds the optimal setup, the tool will generate the shop doc and the code, which is the most important thing for the customer, within 1 minute. And the customer has some standards, has some requirement, best practice. Because, for example, he told us, okay, I want you to detect some pattern on the part. If you, for instance, detect a hole pattern on my CAD part, I want you to clamp the part in the first setup to be able to drill the holes, and then fix the part using these holes, and in the second setup to finish the other features. This was the requirement for that specific customer that we were able to implement. And it satisfies this customer. Maybe you will have another requirement. That's fine. And this is what makes us good at Maya, is we can see what you really need, and we can implement the solutions that work for you and only for you. Because your solution could work for you, but maybe not work for someone else. So we were able to implement that logic, and basically to search for that hole pattern. And if yes, okay, the automation will find the best clamping phase to be able to drill the hole in the first setup and then fix it and machine the remaining features. If no hole patterns were found, we implemented a generic algorithm where we tried to machine the most feature in the less number of setups possible. And then we pushed that tool further by introducing some kind of AI in it. Because let's say you submit a part, it took maybe 1 minute to figure out which clamping phase do you need to use and so on. The next day you submit another part. The tool is able to recognize, okay, I already see that part. It has some similar features on the other one. It's belong to the same family. So instead of trying hundreds and hundreds of clamping configuration possible, I will maybe just try 3 or 4, because I know that there is a high chance that these 3, possibly one of them will be the best pick. From CAM automation, let's move on to structure analysis. I have a bolted joint here, as you can see on the left. And for the people who's doing structure analysis, they know that when you have bolted joint, there is something that happens, it's the generation of a cone of compression. So the cone of compression is an area that is generated where you will have a high concentration of stress. And as the FEA analyst, you need to capture this cone of compression area, because you need to refine your mesh to be able to capture this high concentration of stress. Because if you don't do so, your model will be garbage and useless. And computing the area of compression is a very complex problem, because it depends on multiple characteristics. For example, the type of bolt you're using, the dimension of your bolt, the number of abutments you have. Are you using a head washer, a nut washer with it? Do you have a nut? So you have lots of configuration, and there is no straight way to do that. So here are the business challenges. The customer wants us to be able to perform an accurate FEA analysis using automation and customization. And he wants us to support an exhaustive library of hardware components, of bolts, washer, and nuts. So the tool should be able to detect what type of bolt, nuts, and washer we are dealing with, and be able to do the computation by itself. And finally, we need to keep in mind that, okay, it's not a one-time process, because let's say you compute this cone of compression, then the next day the engineer decide to change the size of the bolt, or to use another type of bolt, or even decide to change any dimension in your model here. All the calculations should be updated automatically. You don't need to repeat it if you change anything in your model. Doing this manual work I've worked with engineering doing this. Take up to 1 week to calculate cone of compression, and if there's any updates, you need another 1 week to do the updates. What I will show you today is we developed something where in between 2 and 3 minutes, we were able to compute in an X the cone of compression region, refine the mesh, and give the FEA analyst a already mesh where he can capture the high concentration of stress in the area in the cone of compression. So here is an example. Here we have a model where is multiple bolted joint. You open a tool, you just need to select, okay, I have 2 abutments here. Here are the top face, bottom face of my first abutment, top face and bottom face of my second abutment, and you're done. You click OK. The tool will be able to detect the bolts, the nut and the washer. See it here. We'll go into your hardware components part, take the relevant measurement, and do the cone of compression calculation for you. And since we are using an X, everything will be driven by expression. That means that if you change anything in the future, any dimension, any size, all will be computed again automatically. The model is up to date, and it's a one-time process. You don't need to revisit your model. It becomes a parametric model for you. So I'm not sure if you are seeing, but what we do is go to every abutment, and for each abutment level, calculate the cone of compression diameter, create the circles, then divide your abutment face by this circle, and then refine the mesh within these circles. And of course, the cone of compression diameter will vary depending on at which level you are. So for example, here on this level, you see you have 2 circles that collide. The tool is able to manage this. He will go and take that face, divide the face by the cone of compression circles on that face, on that abutment. We'll do the same for the other abutments. For example, if we pick this one, and so on. And all the diameters are linked by expression, so you just need to change anything in your model and everything will be automatically updated. So what is the business value of such tool for people doing bolted joint analysis? First, it can be used by non-FEA. You don't need to be an expert in FEA to do such analysis because everything is done for you. You just need to define where are your abutment, your bolts, your hardware, and you're done. It significantly reduced analysis time. So we're going from week of work to few minutes. It removed any human error in the process because you agree with me that doing this type of analysis, it's very easy and common to make mistakes. And finally, it's a one-time process. So you build your model, it's parametric. Any update that happens in the next day, in the next week, is automatically handled by your model. So I show you 5 examples. These are, as I said at the beginning of my presentation, a subset of what we have done at Maya regarding automation and customization. But what I want you to keep in mind is by embracing automation and customization in your organization, you will save a lot of time, resources, and for sure, money. And you can allocate that to other challenging tasks within your organization. Second thing is the competitive advantage it will give to you. Because today, if I take in the market 2 companies selling the same product or the same service, the one that will embrace automation will outperform its competitor for sure, because it will achieve faster turnaround and it will reduce its operational cost. And third is future-proofing, because today, with all the technological advancement you have, you need to react quickly. The market is changing. And if you embrace automation and customization, what it allows you to do is to be agile and to be scalable. And why to choose Maya HTT? The reason is very simple, because we have done a lot of automation and customization projects. We have more than 100 projects completed, especially in NX Open and NX in the last couple of years. We have, in parallel, development expertise. I don't know if you know, but lots of modules in NX today have been developed and authorized by Maya, for instance, PCB Exchange. And we are not only good at doing automation and customization, but also integration, because sometimes you have a workflow, you have a software, it's very powerful, but your software does not talk to other software in your workflow. So what we are good at Maya is take every piece of your workflow and make them talk to each other. That's it. So thank you for your attention. This is my information. I will be here at lunch. If you have any question, please feel free to contact me, and I will be really happy to answer all your questions. Thank you.